Hello there, my name's Vince from My Mate Vince, and in this video today we're going to be trying to fix up all these Amazon return products here. So these have all been returned to Amazon from customers because they're faulty, or they're supposed to be faulty. So we have a variety of stuff going from a Turkish lamp, a bug zapper, an air cooler, a toasty maker, and also something here which I don't know what it is. It says something about insert a kibble. I don't even know what that is. Let's get started and see if we can get any of them fixed up.
Swamp cooler.
So here we have an air cooler. It's powered by USB, 5 volts, 2 amps, and I've plugged it in and there doesn't seem to be any life at all. This one seems completely dead. Right, we're going to plug it in via this, see if it's drawing anything. What I like is it says do not put the fingers and other body parts into the fan. That's interesting. And it also says here, please do not put the product in the fire to avoid explosion. Do they really have to write that? Now, let's plug it in here and see if it is drawing anything. No, so it's not amps there. So we're going to, actually, let's double check it's the lead, make sure the lead is okay. Let's put that into my phone, see does it draw anything. Yes, so you might have heard that, and you can see here 0.68 amps. So the lead itself is okay, so it's something in here which is not working. Now it looks like we have 4 little covers here. So let's undo them, and then hopefully that will give us access. This doesn't look like it's ever had any use, so it might be something really simple. Now if you haven't seen my videos before, these are trying to fix videos. I haven't worked on some of these products before. I might have worked on other ones or something similar. These are just little sticky pads here. So it's going to be very similar to maybe you trying this at home yourself if you're not a professional. And even if you are a professional, realistically, you're not going to be a professional in a whole range of different products. So hopefully there might be some entertainment to be had. It's always interesting just seeing the faults of different things, even if I can't fix it, if we can see why things have failed. That there is most of the interest. I'm going to use my special screwdriver that opens up absolutely anything, and it opens up this as well. I think there's 2 holes here, so we might have to undo these. We might have to take the sticker off. Let's see. No, that's good. Okay, so that goes down to there. Now, where do we want to go to begin with? So the USB port is underneath here, and we've got a ribbon cable going up here. That all looks relatively intact, doesn't it? That's spinning nicely. So I suppose the first thing we'll try is in here, and we'll see if there's power at least getting into this bit. And then we probably have to follow the ribbon cable up into the touch panel at the top. Well, that slides out there. Nice. What do you see here? Water damage. Interesting. Quite a lot of water damage if you actually look inside here. So I don't think the power is going to be getting through the USB. Look at the water damage in there. Right, it's hard to focus, but you can see it all in there. Right, now, have a look at this board. Let's see what's going on. So could it be the tracer's just gone through there? Let's have a look on this side. This side looks quite clean. I think it's just going to be trace damage on the other side. So I suppose we'll plug it in and we might be able to get a reading from there. Does that go all the way around? I'll tell you what we'll do. Let's clean it with IPA. Let's see what it looks like. Right, I'm using the Wonder Stuff, isopropyl alcohol and 99.9%. And we'll give it a nice good clean and see what we're left with. It's amazing how this stuff makes something that looks a mess look so good again. You can already see how much better that looks. Well, let's zoom right the way in. Let's see if we can work out what's what. So that's fine, that's just the ground. So I think, well mind you, that goes around. So I bet you we still have continuity between there all the way through here to here because the path's big, but I think these wires, I bet the wires have gone. There, I bet they've gone there. So I bet there's no power getting up to the top side of the board. Well, let's get our meter on continuity. So it beeps when we touch these together. And let's go between the wires here. Let's just see if they're here. Yeah, are they here? No, they're not. So it must be broken through here. Don't seem to have them here either. Let me just pierce through here. Got it here. Have we got it here? No. Well, look at that. We haven't got it here. So we've got it here, but not here. So it doesn't look bad here, but it must have worn right the way through. Let's see if we've got it between here and here. Should have. Yeah, have we got it here though? No, we haven't, so it's gone there as well. Now have we got it between here and here? Yes, we have. So it looks like it's gone in this section and also this section, even though look at that, it doesn't look that bad, does it? Right, let's just get the tweezers and just gently scrape and see if we can see. Quite weirdly, that doesn't look bad to me. Look at that, you can see it's just all flaking away. Look how much the water's gone in. Look at that. Wow. I'm barely putting any pressure. If you go to a good part, you see that's never going to wear through. Right, we're going to have to get the grinding pen on this. And let's go through here. And also here. Yeah, you can see it's broken right the way through there, and also it's broken right the way through there as well. Okay, that's going to be easy enough there, but it might prove a little bit tricky with the wires through here. Oh no, it was over here, wasn't it? Yeah, I don't really know what's going on there. Let's try to zoom in on that bit. And also, where are those ones there? So that's feeding this bit, so they're not going to be getting there either. To the top of that, I don't know if it's a voltage regulator. So I think we're going to have to do something there, and also around here as well. I think I'm going to have to take off the capacitor, because it looks like we have 3 wires here, so I need to find out where they go to. So there's no point in me doing any work on the other side at the moment. I need to take that off. Let's see if we can disconnect these. These are just plugged in. They've got a little bit of glue on them. That one doesn't want to come off. There we go. I'm going to use some low melt solder with some flux. I'm going to try to take off that capacitor. So that way then with the low melt solder, hopefully I won't have to use heat on it, because that's just going to put unnecessary heat into that capacitor that might make it fail or pop. Let's see if this will work. Not sure if enough of that solder is going to get underneath or not. Can't get under the cap. That's annoying. Oh, there you go, it's lifted. Right, that side is lifted. So let's put the tweezers underneath. Try to heat up the other side, it might pop off. Come on, there we go. Right. You know, I forgot to look at which way was the negative, but I presume those lines there are going to be the negative there. I can always look back at the video. Let's get some solder wick and get rid of that solder there. And we'll give this a nice good clean up, see what we have left. So you can see those wires there are completely gone on this side. So all three wires are on the same rail. I'll zoom in and see what's happening. So I presume then that resistor is on that rail going up to this part of the capacitor, and this is just all on this big rail here, I think. Let's just scrape that there. So this is the... Oh, well, sorry, I was going to say this is the ground, but it's not. This is the positive. Yeah, because the lines here are the negative. In fact, you can see the shape of it. You can see the shape of the capacitor like that. And look at the shape of this capacitor. So the square part is the negative, and the bevel bits are here. So that is the negative. So this is the positive here. So this is coming in from, it must be this here. This is the ground, isn't it? And this here, these ones, that one and that one there, are going to be the main one in, which is not going to be getting to here, I presume, because the wires have gone. Let's just double check that. So that's going to be ground, which goes to here, yeah, and then these ones here is there, that one and that one, which I presume goes through to the other side, which should come up here, and it doesn't. Let's just see if that is coming up the other side. So 1 second, let me just try to rest that on there. So let's see if it's coming up here. Here, no, it's not. Why not? Oh, and sorry, it goes up through here. It must get switched on from here, and then it powers it through to here. So the problem we've got is this is the feed. So this is the feed, which goes through the other side, which it's not. So I have to get the capacitor back on, and I have to put a wire from here around the board to here, and then jumper from here to here, and jumper from here to here, and I think we might be okay. This is all ground here. Yeah. Okay, now I just want to make sure I've got enough room, so I'm just going to slide it back into the casing, see how much room I have to run these wires. Right, so you're going in there with that there, so I can't run any wires. I definitely can't run any wires around the side. I don't think I've got room to run them around the front. So I'm actually going to have to run them through the board. Oh, also I need to check the wires here as well, because that's not going to get across to there, is it? So let's see if the wires are intact to that, let's call it a voltage regulator. Nothing that side, nothing that side. So we're going to have to, I think we're going to have to get a tiny little drill and drill through here and drill through here, and then run the wires through the board. Either that, or it's a case of running them all the way around this side to here, which we could do. No, what we'll do is, there's quite a few holes, and I don't know if that's for currents, you know, rather than just a tiny, tiny one little hole, because there's quite a few holes on both of them. Let's just drill a bigger hole and shove a bigger wire through. I think maybe a 1mm hole might do it. No, I think I've broken my 1mm bit. Right, 1.2. Let's see if that will do. So if I just go through the edge here, then hopefully I'm not going to hinder the capacitor. Am I going to damage anything else? Does this outer one do anything? No, it comes to here and stops, so it makes no difference. There's nothing on the outer one. This is all one here. So if I was to go through here, I should clear this rail, and I might still be able to get the capacitor to lie relatively flat. That might be too big. I think that's going to be too big. Right, this is 0.85, so a little bit less than 1mm. My mate Vince Massive Time. The members this month are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJVG, Pigsy, Russ Melanson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from the Broken Past over on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, Garin Shaw, and Lady Leona Drury. Many thanks. Now, your turn. That's bang in the middle there. I've said it many times in my videos, but don't copy what you see in my videos, because lots of times I do things that are incorrect. I don't know if this is the best way to do it. What I would say though is this board isn't a multi-layer board. It's top and bottom. It doesn't look like there's going to be a load of levels in between that have traces going everywhere. If this was something like a PlayStation 4 or PlayStation 5, Xbox, etc., you're not going to be able to just drill through like this, because you could be damaging wires in the middle that might be going off to other areas. But this is just top and bottom, and I can see the top and I can see the bottom, so that's why I'm happy to drill through. There we go. And we are... perfect, look at that. Nice. Right, let's get 2 wires to go through there. Then we need to try to solder everything up. And I didn't break my drill bit. Right, I've got some old telephone jumper wire here, which is 0.5mm, and this hole was 0.85mm, so you can see that's going to go through nicely and there. And I think there's going to be enough, I don't think there's going to be a problem with any current going through that. If you could put down in the comment section, is that why we have more wires, to allow more current to go through? So really, I think I can put this back in place now, because we can just go straight onto that leg there, can't we? So I'm just going to put solder on one of the pads. Then hopefully I can melt that side and push the capacitor down onto it, and then I might be able to do it with a soldering iron rather than hot air. Oh, hold on a minute. I don't know. 1 second. I don't know. Is that copper or is that eaten through there? Let's have a look. So that goes to here, yes. No, that's fine. So that's just copper. I'll cover that with solder. Then I won't have to put any UV mask on it. There we go. That's plenty solder there. Let's pop this down. And I'm putting the negative side here. Let's try to melt it all, place it down, let go. Is that straight? Not the best. No, I'm over the resistor. Very little room to work. Let's try coming at it from this side here. There we go. Right, That's on there. So now I can put the wire through and solder up at the same time. So we want to bend on the top of this. Where's it gone? Oh, there we go. So I should be able to flood that whole area with solder. Oh, I'm putting loads in. There we go. Do you know what? Is that still going to be able to slide in, I wonder? Maybe not. That might not be able to slide in. You know, to the housing. I'm going to have to get rid of some of that. Right, well that's connected there and it's a lot flatter. Hopefully that will go in. Now we have to sort of try to bridge this across and then flood it all with solder everywhere. I think that'll do. There we go. So that should be the via restored with some nice blobby soldering. You will love it. And I now have to do the same with the other one on the other hole near what I call the voltage regulator. So same thing again, just putting the wire through, soldering up, and then trying to restore the track with a load of solder. This one here, I don't quite leave a long enough wire, so then I have to add another wire to bridge both sides of the brake. It's amazing, like it's easy to get a nice blobby solder joint, but it won't stick. If there's like a gap bigger than 1 mil, you're going to really struggle to get the solder to bridge that. You can lower the temperature of your soldering iron down and you'll have more chance of dragging the solder across. But in this instance here, I've just run another wire on top there. I have to check for shorts because these tracks are quite close to each other, so I have to make sure that they haven't shorted onto each other, but they haven't. And then what we need to do is we need to put a load of solder mask everywhere, because you can see all this copper is exposed and it's going to oxidize over the next few weeks, months, years, etc. If this thing lasts years, who knows. Anyway, let's pick up the video as I'm about to use the world's quickest setting solder mask. Right, so from here to here. There we go. Right, and we're not shorting between here. So let me put some solder mask on that and then we'll test it. Right, this stuff here, Mechanic, 3 seconds, fast drying. Watch this. So put a nice dollop there. And we're going to need some of the other side, aren't we? Probably not actually. I'll put a little bit here, over that bit, and just over that bit there. Now, I say it's the world's quickest. To me it is. I don't know if it is actually or not, but it makes using it enjoyable. And I hated solder mask before. I used to just use nail varnish, but this stuff is better. And now it's become a joy to use. You know what, that was a bit silly. I should have tested it before doing that, but I've covered it in rubbish now. if you haven't seen my videos, don't copy what you see in my videos, because there'll be lots of incorrect things done. For example, I shouldn't be putting this on here now, because if it doesn't work, I've made a load of work for myself. But watch this. So let's plug it into here. Turn it on. Watch how quick the UV light will set it. So get my fingers out of the way. Now I've put it on really, really, really thick here. So I'm going to leave it more than 3 seconds. But even after that short amount of time there, I will do it longer, but watch this. Watch this. Look at that. It's nearly gone. I can see a slight imprint, but that's nearly gone. Look. In fact, it might have gone. It's amazing stuff. So that is this little board, hopefully repaired. I think if it does work, it should be a lasting fix. I'm quite happy with the repair. Comment section will probably tell me otherwise. Anyway, let's get it back together and let's see if it starts working. I'm going to go here, here, and here. You ready? Okay, not drawn anything, but we haven't turned it on. Are you now going to turn on? Yes, you are. We got a light. Amazing. There, we've got a fan spin. Excellent. Lewis Rosman would be proud of me. That's debatable. Now let's get this back together. I'm going to work out how it works, and let's show you hopefully it fully working in the other room. Right, I've been reading up about it, and they don't sell it now. It looks to be a £30 device, and it's supposed to be I think it might have said a 4-in-1, but essentially it's a fan and it's also a humidifier, not a dehumidifier, a humidifier. Now I've filled the top with water and it works as a fan, but when I put it onto the actual humidifier part, then the atomizer should be atomizing the water to make a mist to come out. And I've had it on for about 5 minutes, and as far as I can see, I don't think there's any water coming out, so I'm not sure if we have a blockage up the top, which might be possible. It might be blocked up with a bit of scale. But anyway, if you look at this now, it's turned on, and it looks like there's 4 settings. So if I hit that there, that's setting 1. It's nice and quiet, and you can move this around to angle the direction of the fan. That's 1, 2, 3, and even on 4, it kicks out a fair bit. I mean, I can feel that. I can feel that here still, which is, well, even a metre away now. I can feel it there. So that's not bad. And we have lights. And it will cycle through the different colours. That's working. And oscillation is working. But when we have it on this humidifier part, I don't think it's working. So I've got a Q-tip. I can see 2 holes because I want to be careful because it's full of water up the top. There's two holes up here. So I presume there should be some sort of mist coming down from the top, and it's not doing that. And I can see in here that we have 2 holes in here. So just you can see one there and one there. So I just want to go in here just to make sure that it's not, you know, blocked up with something. In fact, maybe if I do this when it's on, it might force stuff through. So let's put it on now. Put it to setting 3, and I'll put it to full. Oh, I can already hear it hissing. I can hear it hissing now. And I can see bubbles coming up. I can see bubbles coming up on both of them. They seem to be coming up a lot on the right hand one, not so much on the left hand one. Now. It sounds noisier. I'm not sure if that's coming off in the... probably can't hear it in the camera over my phone. Right. Well, it's hissing now. I'll tell you what we'll do. Let's put this back on top. And hopefully I can still hear it fizzing. We should be able to hear the difference. And the bottom tank apparently is to collect the so it doesn't leak. But what I'm not sure about is I've definitely seen wires go into the bottom. So I thought the atomizer was at the bottom, but I don't think it is. Yeah, it's fizzing. So if I do this now, can you hear now the fizzing stopped? Let me bring the camera right down. So it must be working. Ready? That's 1 setting. 2. If I turn it off, You can hear the fizzing goes. Right, so let me just leave this on for a few minutes, and then I want to see if I can actually witness any sort of mist coming out, or whether I can feel these getting any bit wet. Right, 100% it's working. I can see mist coming out. I just can't seem to capture it on camera, but I can see the mist coming out here. All around this area here is really very visible, but it's so fine. And I don't think it's coming across in the camera. So you'll just have to take my word for it. Hopefully you would have heard it fizz. So there we go, and oscillation is working as well. So I believe these are kind of called swamp coolers, and they would make it a little bit cooler because of the water in here. You can also add ice cubes as well. Personally, would I get one? No. Is it worth £30? I mean, you wouldn't be able to make one for £30, but I'm sure if you spent more money you'd get something that actually works rather than something like this. But they seem to be all over Amazon and eBay, so clearly there is a market for them. So yeah, I don't think there's much of a resale market for them. I think people just buy them from Amazon out of ease, and they're cheap enough where they don't really have to think too much about buying it. Anyway, I think it's working, and I think it will be a lasting fix.
Turkish lamp.
Here we have a Turkish lamp, and although there's a lamp in it, it seems to be completely dead. So let's take over to the mat and see what's wrong with it. Right, Turkish lamp, what is wrong with you? So let's first of all check fuse, and we'll just go through some basic fault finding and see if we can find out what's wrong. So meter on continuity. So the fuse is okay, but we don't know if the switch is okay. So now let's see. That is kind of half off already, so I could probably peel that quite easily. Yes, I can. But I can see that the cable just goes straight up inside there, so we don't really have to worry about this. Let's just put it on a bit better. There we go. Let's go straight up here. Now I don't know if this is LED or incandescent. It's a screw terminal one. I should be able to use continuity and go from here straight to the terminals. 6 watts, that's going to be an LED one. I don't think I've done this before. I just want to see if I was to go onto diode, would anything come up on here to suggest that this is working? Because with an incandescent you can just use ohms. I just want to see if anything comes up there. No. No. Not sure. It's not showing anything. We are in the mega ohms, so maybe there is something there. Right, let's go between. Let's just use continuity, and we should be able to go between these terminals here. So we go onto the middle one, and let's go here. Yes. No. So that's there. Let's see if it's still there. Yes, so the live in the middle is not switched. Okay, let's go on to the neutral. Not here. Not here. So the neutral is not here either way. So that might suggest that that this is faulty. That's a bit annoying, because that is going to, I presume, be clipped together or welded together. Yeah, right, let's not worry about that yet, because I did a lamp before and it was faulty on this bit down here. So let's see if I can take out this bottom bit. I don't want to break this because this is glass. It's very heavy. Oops. Ow, ow, ow. It's very heavy, so you can see it's done in some sort of plaster, and then these are all pushed in on it. So it might actually look quite nice when it's on. I'll try not to break that. So, neutral, why are you not getting here? And how does this come off? Right, well I can see that we have here and here it's joined. So I might be able to prise it up from there. And then if it's all okay here, unfortunately it means that we're going to have a problem in here. It's a tough one to undo. There we go. You're going to come up. There we go. Yes. Right, look at that. So now we have access right into here. You can see it coming up. Brilliant. So now we can prove 100%. I think with these, you push in here and that will come out. Will it come out? They're under pressure. Let me get my glasses on. First of all, let's just go straight onto that prong there. So is that connected to here? Yes, it is. So if we go there, it's still not coming. Oh, it is coming up. Hold on. It is coming up here. Wait a minute. So you're there. No, you're still there. What am I doing wrong? So it's the live one. Wait a minute. Beg your pardon, it's the live one that's not. They've put it in wrong. The live one should be this one here, and then the neutral should be that one there. Not that it would probably make much difference in this one here, because you can't really get your finger in there anyway. But yeah, that's been put in incorrect. So it is the live one which is not getting there. And it is the live one which has switched. Right, okay. Forget how these are put in. I think I've got to slide it in this way to then take them out at the same time. There we go. Well, they're in wrong anyway, so let's take them out completely. There we go. Right, so if it doesn't work on here, then it has to be here, because it'd be unlikely. Well, of course, unless it's failed just here, which is a possibility. Neutral's definitely working. Live. Oh, live is working. Is it switched? Yes, it is. Excellent. So it is. Hold on. I definitely heard it beep. 1 second. I think the switch is intermittent. It's working now. No, it's not working. No, it's working. Hold on. Well, a little bit annoying there because I'm not 100% sure, but I think it must have been where it's going into here. It's not happy. Maybe what happened before when I did one. I think it might have been a Tiffany lamp. I think this was pushed too far through. So if you have a look, in fact, I think this is it. Have a look at the difference here. Can you see the blue goes right the way up? The brown doesn't. And I think the brown's been pushed in too far. So the metal contact, so imagine this is the wire and this is sprung loaded here. It goes in and it just does that. And it grips onto it, yeah? But imagine if the insulation starts here on the blue one, then you can see, boom, it's on the wire. But imagine if the insulation starts here on the brown and then it goes in to the brown there. I think that's what it's done. I think it's been pushed in too far. So I think all we have to do is strip back the brown a little bit more. In fact, you can see it does look like, have a look there. I mean, maybe this was when they were stripping it back, but maybe, I wonder, was it gripped onto that bit? Possibly. See what I mean? That's probably where it should have broken. So let's just go onto here and do that. And now you can see there's much more brown exposed. Right, so we want to put it on the correct one. So I want the brown to be on the middle contact. I'm just going to put this back in. It's a 3 amp fuse, which I presume is correct. So we want this side here to be... Right, so that is what I would call the neutral, and that middle one, which is going to be this one here, because I suppose otherwise what could happen is you could be unscrewing it, and if this was live, let's have a think. Yeah, I'm not sure in this instance here, but let's say if you were unscrewing it and you had tiny fingers, you could maybe touch that while it was still connected to that one, which is live, which is this one here, while grounding yourself against something like a radiator or something like that. I know it's unlikely. So where am I? So let's do this side. There. So we want the live to be in this side here. So let's just push it in. Like that. It's not going in. There we go, now it's in. And put this one in here. Like that. Right, they're both in. Let's just now make sure that neutral is neutral. So N for neutral. And the outer one here. Excellent. And live here is going to here, switch it. Not going to here, switch it, is going to here. I think I mustn't have been in it right when I was doing that switch there. I think the switch is okay. So let's bring that back through. Now it doesn't want to go back through that way. Why? Right, that's clipped in there nice. Now you want to go through. Okay. Right, that's there. I'm going to put a cable tie on that, just to add as a bit of a strain relief. There we go. Oh, that's nicer. Let's now see, does the light itself work? And then we can save the big reveal to the very end. Plugging it in now. Oh, we're on already. Boom. And that makes sense. Oh, I can't see anything apart from a light. You can see that that's off there and there's a little little line there. Fantastic. So that's all it was. That brown wire was pushed through too far, so the contacts were on the insulation, so there was no contact with the actual bulb itself. Right, let's plug in the actual Turkish lamp part and see what it looks like. Right, here we go. Will it be underwhelming like the Tiffany lamp, or will it be surprising like the wax warmer? You ready? Well, that is more surprising than I thought. But these look like they're dirty, but I did rub my fingers on the inside because I thought it might be just like white paint, you know, plaster. And it didn't come off easily, but I think really they would need to be cleaned to make it more see-through on those ones. That is, if you were in the market for a Turkish lamp, that isn't too bad. I'm not underwhelmed or overwhelmed, but it was a nice easy fix and well worth fixing.
Bug zapper.
Here we have a mosquito killer. A bug zapper, but this one's slightly more fancy because it has a remote control. Why you would really need a remote control? Well, maybe if it was up high and you were out in a veranda or something, it'd be easy to use this to put it on timer and to turn it on and off because you might not want it on all the time. Anyway, it appears to be working. I think the lamp has just gone on one of them. If I turn it on there, you can see it comes alive and we have a timer down here. 2 hours, 4 hours, 6 hours, 8 hours, 10, 14, no 12, and then 14. So that all appears to be fine. And if I put an insulated screwdriver in, there we go. Isn't that great? So I suppose just to prove that it is definitely the lamp that's failed. Right now the top one's working, the bottom one's not working. Let me just take it apart just off camera. I'm going to swap them over, and if the bottom one starts working and the top one's not working, we know definitely it just needs a new lamp. So I had to take the lid off here. Very hard to get in here because you've only got access at the side bits here because the grid here is in your way. Now I've swapped them over and I think I know what's caused the problem. If you look at the grid here, it's nice and straight, and if you look at the grid here, it's nice and straight apart from this one here, which is right the way in. So I think what's happened is customers probably got this one, dropped it, which has now stopped the light from working, and then just sent it back as faulty. So yeah, I don't think it would have left the factory with that big dent in there. So I'm just going to straighten that up, but yeah, it definitely it needs another light, because I've just plugged it in quickly like this without the covers on, making sure nobody's going to touch it. And if you have a look, the bottom one's working now, not the top. So this one just needs a new lamp. Right, I found a spare lamp, so now we have full operation here. If you did want to buy them, they're $12.99 for 2 of them, next day delivery. You probably could get them cheaper, but Amazon make things nice and easy for you. So £6.50 per lamp. And if you have a listen, there we go. And that's how the bugs meet their ends. But although it's down as a mosquito killer, apparently these are more likely to kill moths and flies and stuff like that rather than mosquitoes, because I think mosquitoes are not supposed to be drawn to the UV light as much as things like body odor and stuff like that. So yeah, I don't know how good these are at actual mosquitoes, but if you want to harm moths, and I personally like moths, then this is probably what you need.
4-in-1 toasted sandwich maker.
Here we have what I would traditionally call a Breville maker, but maybe they were one of the first ones to make it here in the UK. It's like a toasty maker. So it has all different inserts, which is quite nice. You can see here, this is what my one would have looked like when I was a kid. Looks like you can do waffles. Not sure what that one's for. And then you have this one, which I'm thinking might be for little mini donuts. Anyway, when I plug it in and turn it on, I can't feel any heat coming out, and also I can't see any lights coming on. It's definitely had signs of use, because I can see what looks like old food or mould around here, but yet these all look perfect. So maybe the original person who sent it back didn't send back the original inserts, but it's nice and easy to change the inserts. You just do that, and then these pick up, and you can see we have a heating element there, and we have one up top as well. Definitely looks like there's some burning along here, so I don't think this is going to be fixable without probably buying some spares. And would I buy heaters for something like this, elements? No, because I'm pretty sure you'd be able to buy the whole thing for less than you could buy the elements for. But let's see if we can at least prove what the fault is, and you never know, fingers crossed, we might be able to fix it. Right, first things first, we need to check the fuse. It is I presume it's going to be a 13 amp. 13 amp, correct. Well, I say correct, I don't even know what watts this is. Can't see a sticker on it. Okay. Fuse is okay, and you are wired up okay. Right, so next we need to get into here. So we have a screw, and I presume screws underneath these little rubber feet. No, we don't. So, would it be... What's keeping that together then? Oh, screws around here. I can see something that looks like a thermal fuse there. Could well be that's gone. And when it comes to burning, this is very brown around here, but look at that, that looks like new. Actually, I suppose all I needed to do was undo those four properly. I'm not sure if I'm going to gain anything by taking that off. Don't think so. Obviously, I am unplugged. Whoa, there goes the hinge. Now, what have we got? We've got some what looks like batter down there. And I think first things first, we need to check this thermal fuse, because that's probably going to be the most likely thing that's gone. Because otherwise one of the elements would be heating up, wouldn't they? be unlikely that both elements have failed at the same time. So I think it's going to be a thermal fuse issue. Right, let's see if I can go through here. Wow, no way. Yes, it's not a thermal fuse. Well, next thing to check would be the elements. So let's go to continuity to begin with, but then we'll check on ohms. So we have the element here, which looks like it's the kind of burnt one. Here and here. No way, we've got it, 37 ohms. Well, this is getting more interesting. So what could it be? Right, let's follow the path. This comes in. Should I undo this just in case there is some weird connection in here which has gone? Got a load of black stuff. Oh, let's just undo these two things just in case that isn't the same wire that's in here, because this is all braided. Might be fixable. Aha. Has a crimp failed? No, we have got a strand sticking out there. Let's cut off that strand in case it was ever to work its way into one of the others. There we go. Right, let's do a continuity between the plug and here. So, earth. Definitely getting to here, so that's okay. Live is going to be the brown, which goes onto the red. And that's okay. Neutral is the blue onto the blue, and that's okay. So we know the cord itself is okay. After that, it goes to here, and then it goes through the thermal fuse to up to the next one. So maybe there's a thermal fuse on the top one, or some different fuse that's failed up there. So let's see what's happening up top, because it goes up on the white wire. Well, maybe it isn't held in, maybe it is, maybe you do need to undo these. Right, so we have a spring there, let's not lose that. Now, oh, okay, it goes up to the LED. Right, how do I get more slack? Let's undo this here. Right, well, let's check this top one, this top element. I wonder if the LED's failed. Would it? Oh no! Look, magnetic screwdrivers. Just I had all these in some sort of order. Should be okay. I wonder if the LED had failed. Would it stop it power from going through and making it work? Well, that's working, and it's a similar ohms to the other one. And then we've got a ground going up to the casing at the top. So this here is going to be in contact with here. That's all fine. Right, so we should have, the white comes up to here, then the white goes up into here. So is it a problem in here? We've only got one screw holding that in. I presume there should be two. And then we have two massive, what look like kind of neon lights. And they look like they're melted in there. So I don't know how to test, if I'm honest with you, I don't know how to test a neon light. I don't think they're a normal incandescent. If they had gone, let's just pretend now that they've blown. Let's just see what happens. So let's go to the the neutral, because the neutral goes through here. So the neutral goes through here. Neutral also goes back up to here, and it goes to, the neutral goes up to, I'm not sure, one of these lights. And the other end of the neutral ends up going through here and becomes a white wire that goes through the hinge and comes up here into the element here, and then goes off to here, and then the red one goes back down, so we know it's going through there. So if the lights weren't working, there would be no power going through the elements, I think. So the only thing I can see which is not working is the neon lights. So we should be able to get it right from the plug right the way into here. So earth comes up to here, so we know the earth is okay. Let's go on to live. So we haven't got anything there. Let me just check on ohms. No, that doesn't seem right, so maybe that's our problem. So let's go through the live bit by bit, because maybe I've missed something. So live comes up and it goes straight into this element here. So we should have a full-on short here. What? We don't. We don't. But yet we had it here. So has the crimp, has it failed on the, somehow where it's been bending? Because we had it here, didn't we? So let's go back to here and onto live. We've got it there. That goes up through here. Ah, there's going to be something hidden in here, isn't there? There's going to be something hidden in here. So now we haven't got that to here. So if we go onto live here, we haven't got anything. So something is hidden in here, which is probably going to be a thermal fuse. Now reveal your secrets. Ready? Come out, come out, come out. You're a thermal fuse. Quite a burnt thermal fuse. Right, okay. I might have one of these because I have bought loads, but they're one of those things where no matter how many you buy, the one you want is never the one you have. So let's zoom in and see if I can work out what the readings are. Well, actually, before we do that, let's just make sure we do not have continuity through it, just in case I was on it weird. There. So it's dead. Continuity, continuity, but not through it. Right, let's see. It says what you are. You are TF 240 degrees. And it's a 10 amp. Surely I have to have one of them. Oh no, actually I think I've got all 5 amp ones. I'm not sure. Let me have a look. I need a 240 10 amp. It says at the bottom there. And TF 240. Fingers crossed I'll have one. Yes, hallelujah. My incessant thermal fuse buying has finally paid off. And I've got the correct one, 240C. You can see CPC. These ones are a thermodisc, so it's a different brand. But this one is FF0134. And if you have a look here, FF010, 34. And you can see 10 amp. Functioning temperature, 240. Yes! Fantastic. So let's pop one of these in. I'm actually going to try to crimp it in rather than solder it. And it's a 5-pack for £3.32, that's excluding that though. So you have to add 20% onto that. So you look about £4. So just under £1 each. You have a listen here. Continuity. Nothing here, but something here. So maybe it will fail again because maybe this bottom element is not working right, or maybe they did something wrong. Maybe they left it on for far too long. Maybe they left some waffle or something on it for absolutely ages and it was just burning and burning and burning, maybe with the lid up or something, not too sure. Right, so I've got these crimpers here which are open-ended. I've got these ones which are closed, so I won't be able to put them on. Well, I'll be able to do one side with these and then I can do the other side with these because obviously I won't be able to remove the tool from this because it's enclosed round. And I'm going to just cut open some of these ferrules to get the to get this part off it, so I'll just cut off the plastic bit there. So let me work out which one I need. So red is going to be too small because I have to get the wire in there. Blue I think is going to be too big, but I think, as Goldilocks would say, this black one here might be perfect. So let's just cut this away here, or let's try to just push down. Is that going to work for me today? No, I don't think so. There we go. And we need two of them. Right, let's cut off this one here. And I've got to try to expose some new wire. Like so. So to get that in there and this in here at the same time. So I'm going to make them slightly oblong. This might not be big enough. Whoops. Got it. Just trying to force it through. Well, that's pretty tight. Right, there we go. Can you see that the you might not be able to see, it's gone right the way through there. So let's use this tool, and this is like a hexagon. It goes all the way around. It's really nice. I don't often use it. It grips it all the way around, so hopefully I can get that through there. Just put it onto here and crimp down like so. And there we go. That should be a good connection there, but I can't use that on this side, unfortunately. So I have to do the same on the other side, but use the open-ended crimping tool because then I can take it off again. And then I realised that I removed one of the heat shrink tubings to be able to get more access to the wire, and I forgot to put it back on. So I have to cut it and I have to redo it, which is a bit irritating, but I only have to redo one side, which isn't quite as irritating. So then all I have to do is put it all back together and give it a nice good clean up. Now obviously this video is long, so I'm just going to whiz through that bit. Next time you see this now, it will be back together. And we've got a nice new thermal fuse. So before I plug it in, I just want to check with my meter to see if it might be safe to plug in, because we should be able to see the elements via the plug. Also, we should be able to check between shorts between live and earth and also neutral and earth, all on the plug. So let's do that. Next time you see this now, it's going to be a bit cleaner and all back together. Okay, I've given it a clean enough that I feel confident using it without making myself ill. But as soon as you use these things, you're going to get cheese leaking out and butter melting and going down here, etc. So yeah, it's not going to stay clean for very long. Now, I haven't put it in yet. I've put what I would call the Breville Toasty inserts in here. And I just want to check to make sure. My hands are really itchy. Those, I think the wires have a load of fiberglass in them, in those strands there. And you know, when I was stripping them back, I feel itchy all around here, the same way I've been using a fiberglass pen. So let's have a look now. Let's leave it on ohms. So if we have a short, it's going to be less than 1 ohm at the moment on my meter. So this is earth. So we can see that that's still earthed, which is good. Have we got a short between earth and neutral? No. Have we got a short between earth and live? No, fantastic. Have we got a short between neutral and live? We will have, because it's the elements. And it's 73 ohms. And remember, each element was, what was it, 38 ohms or something like that. So this is suggesting that they are about 38 ohms, isn't it? So there we go, 38 times 2. Have I got that right? 60, 76. Okay, so 37 ohms. Right, okay, I think I'm confident plugging that in. Now, maybe there's a reason why this burnt out, or maybe it was user error. Let's just plug it in quickly here, just to see if the light comes on and see if we have any heat building up. I won't bother getting the thermal cam out. There we go. We have a red light there. So I presume it goes to green light once it's up to temperature. In fact, that's what that thermal fuse is. It's going to get up to temperature and probably break the circuit. Then when it cools down, it will, I can already hear it. And, hold on. I'm not talking about the little thermal fuse that I replaced, I'm talking about the big one we tested at the very beginning, the cylinder one, the circular one. Well, those ones I believe are designed to make and break, because I've seen them on tumble dryers, you know, like washing machine and dryers. I've seen them on a dryer, and that's what cuts the power to the element and then makes the power to the element. Then when it gets up to temperature, it cuts the power to the element. I believe that's what this has here. Now I can feel heat. Right, I can feel heat building up now. Right, you know what? I'm going to make myself, turn it off, I'm going to make myself a toasty. Right, I haven't got any square bread. That's the only bread that I've got. So I was going to do 2 lots. I'm not sure if it's bad for these if you only do 1 lot. I don't know. But anyway, I am going to just do my best with this bread here. It's going to look awful, but you're supposed to have square shaped bread, and that way then you will have 2 nice diagonal halves. Yum yum. Gouda cheese, cherry tomatoes. Right, one thing I didn't think of, I was about to say the green light might not be working, but I can definitely see a lot of smoke coming off it, but I suppose that's the butter probably melting and burning. Let me see what it's looking like. Oh, that's looking good. Oh, I might leave that just a little bit longer. So when the green light comes on, I presume that means that it's up to temperature. And when it cools down, that will go out. Well, I'll leave it another 30 seconds or so, or a minute. Right, I think that will do me. So turn it off. And there we have it. Right, let me get a fork, take it out and cut it open. Well, there we have it. That's what I mean by the mess that comes out of it. You can see that the cheese is definitely nice and stringy on the inside there, and we have a bit of crisp on the outside. So I'm going to tuck into that. Is it a good product? I don't know. I'm not sure how worse it would be than a branded product. I definitely like the way that you can interchange these though, because I know when the kids were younger, they would have definitely, or even maybe now, liked to try and make waffles. And instead of getting like a toasty machine and a waffle machine, it's nice that you can do it all in the one. Now maybe they've always existed, but definitely years ago when we had one when I was a kid, it was just like this, and there was no chance to put a donut one in or a waffle one in. So yeah, that's a nice little touch. Right, I'm going to make myself a nice coffee, eat this, and yeah, enjoy. I think it's well worth fixing. A thermal fuse there. Is there any resale value? No, the item's too cheap. But it's worth fixing if you've got one, because then rather than you having to spend another £15, for example, on one, a thermal fuse is going to cost you £1, and you might enjoy fixing things. If you do, then you can't put a value on that, and you've saved it from landfill as well, which has to be a bit of a bonus.
Weekend pet feeder.
Well, look at this. A kibble must be something to do with dog or cat food, because this is a pet food feeder. So you're going to put your dry food in here, and it looks like maybe it's on a timer or something. This thing turns and it must drop food through here into here, and it looks like it's USB powered, or we have the option underneath to put big batteries in as well. So let me get a USB little power bank and let's see if it comes alive or not. Okay, I had to download an app and also watch some reviews on it as well. There were some YouTube videos, and as far as I can see, it's working. I think the problem is a lot of people are saying that it only works on 2.4 gigahertz, not 5 gigahertz. So if you bought this from Amazon and then your router is 5 gigahertz only, well, you're going to send it back. Also, it doesn't do anything without the app, and maybe people were uncomfortable downloading the app, or possibly they were finding it hard to sync this to their router to download the app. So I think it's probably more user error rather than anything wrong with this. Now the idea is you will put some cat food in here, or maybe dog food if it was a small dog, not sure. And if you look here, you can do all different times. I think you can do up to 12. So it looks like you might do 12 different portions, I presume daily, and you can have it on for a different amount of time, so you can choose the amount of food that will come through. So it looks like it's going to be, not quite sure, I suppose it depends on how many times this turns around here. This will loosen up the food here, and this will drop it down into here. We will put some food in a minute, but if you look, if I go to here, 1, and go to feed, you can see that that's turning. Obviously this would be done automatically. You would program it up. Feed. So let's put a little bit of food in there and see if it comes out. And you might be wondering why I would have cat food if I don't own a cat. Well, I now am a proud owner of a cat. It wasn't me that wanted a cat. I've always grown up with pets, but the problem with pets is they can be a bit of a burden, because if they get ill, or if you want to go on holidays and stuff like that, then you've got to have people to look after them. But my daughter went off to university, and there was this stray, and she really was stray. She was tiny, as thin as could be. Her head was massive with big bulging eyes. She was really malnourished. The tail was about this big. She took a liking to my daughter, and of course my daughter then started to rub her, let her in overnight, and then start feeding her, and now the cat's become dependent on her. But my daughter's not there enough, so the cat is now living with us, and as it so happens, the cat then got ill, and so far I've had to spend 4,000 UK pounds. I'm shocked at how expensive vets are in the UK. My mother and father-in-law, who live in Ireland, where it's a bit more rural, where maybe the vets are more kind of sensible with pricing, their cat got hit by a car. It spent 3 or 4 days in hospital, and I think it needed the hip or something fixing, or broken hip, or some kind of plate or something. Came to £500. I take the cat into a vet over here, they need to keep it overnight, and it's £1,800 to put it on a drip and to do a few like ultrasounds and stuff. Absolutely crazy. Anyway, let me get some dry cat food. I'm going to show you the cat as well. Here she is. She's a little bit worse for wear at the moment. She's been through the wars, so we have all these ball patches around the place, but she is lovely. Just had to have a tooth removed as well. She's had a hard life, but she's put so much weight on now. Look at that. I'll be honest, she has entered into my heart now. Often I'm trying to edit a video and she just jumps on my lap and falls asleep, and I find her quite therapeutic. There we go. So her name is Kitty. I know, it wasn't me that named her. Ah, there we go. Anyway, let's get some of her pet food. But look how big her eyes are. She has massive eyes. Good girl. And you might not remember, but I did a water fountain in one of my, I think, Amazon videos, and now it is in. I didn't have to fix it, it was already working, but I was thinking, why on earth would anybody have this? But yeah, it's because cats and dogs like to drink from running water, because I think they probably think it's fresher or safer than maybe a stale puddle. So this has been in operation now. So all the things from Amazon are now finally coming into operation in my house regarding pets. Right, so let's pretend it's feeding time. I've only put a bit in here because I need to wash it all out. But if I go to feed, let's see if it comes through. Oh, that's interesting. Do you see that? It kind of kicked it. Oh, okay, well, it has emptied it out. Maybe it kicked it because maybe some bits got caught in here and they flicked up. Anyway, you can see there that food's there. I don't think there's anything wrong with this. I think it was either user error or the user couldn't be bothered with the hassle of setting it up. Am I going to use it? I don't know. I'm not too sure. Our cat at the moment just seems to eat when she wants to eat, so I'm not sure if I would use something like this, but we'll see. It's useful to have.
My Mate Vaughn's finale.
So here we are at the end of the video, and amazingly we have 5 products working, but this one was already working at the beginning, so we fixed 4 items. This one isn't even a fix, it's just changing out a lamp which they're designed to be changed, so we have 3 fixes, but these 3 were proper fixes. Out of the 3 of them, this was the most challenging soldering wise. That was probably the hardest for me to actually find the faults, because it was the last thing I looked at after looking through everything else. I think probably the most fun for me was actually the Turkish lamp, because it's interesting to see when it comes alive what it looks like, but also I enjoyed the fault finding, going through bit by bit, the fuse, etc., working your way through and then proving what the fault is. Out of all of them, most useful for me will possibly end up being this one here, especially maybe if I was going away on holiday and somebody was looking after the cat but maybe only dropping in once or twice a day. You could have this to maybe feed 5 or 6 times a day, or in the middle of the night, for example. So yeah, that could be useful, and you can have backup batteries as well, so even if the power fails it will work from the batteries. So yeah, not a bad product. Any money here to be made? Not really, because I think most of the money is going to be made by eBay or the shipping people, you know, whoever you post with. But maybe for car boot sales there could be money to be made. The problem is all of these items are going to be around about up to £30, and at that price point people seem happy just to buy new from Amazon without doing a lot of shopping around. When things get over £100, people shop around to try to get things cheaper. But maybe it would depend on the country you're in, because £30 in some countries is obviously going to take longer to earn than other countries. If you did enjoy the video, you can give it a massive thumbs up. I will see you again hopefully in another video very, very soon. If you've made it to the end, thank you so much, and give yourselves a pat on the back, because my videos can be quite long. Thanks for watching, everyone.